So welcome to Math 2's guided note lecture format. We've previously had a discussion about some of these topics, and this is the formal lecture. I record it and play it in class for several reasons. One is if you're ever absent, you can always go to the Google Classroom and see whatever you missed that was covered in class, since I wouldn't be able to cover it again for a particular student. Same goes if you're on a sports team or attending some type of school function. You can always stay on top of your studies by going to the Google Class website and accessing the lecture notes for a particular section. Two, they serve as a helpful way to study for tests and quizzes, and by them being recorded, you can retrieve them at any time. You can reduce the playback speed. You can even equip different language subtitles if you want when you watch this outside of the classroom. So without further ado, let's begin this section. We're going to get into domain, range, and end behavior. You actually did this in Math 1 some. You recall domain is all the x values, right? Hopefully this is coming back. Domain, the x values of a function. Range, right, was the y values of the function. And then here's some vocabulary. An interval is a part of a number line without any breaks. And I'm going to show you examples of all these in just a moment. A finite interval has two endpoints, which may or may not be included in the interval. And, basically a finite interval has only so many numbers within the set. Or so many possible solutions. An infinite interval has basically an infinite amount of solutions or numbers in the set. So an infinite interval, they call that, is unbounded. And you had some experience with growing and decreasing without bound last year when you did exponential functions. So that term unbounded might also be reviewed. Now a set is a collection of items called elements. So if you had a set of baseball cards, you have a collection of them. In math, a set is referring to numbers, a collection of numbers, and they call the individual items of the set elements. So there's several ways you can, demonstrate an interval or communicate an interval of numbers. And one is interval notation. I want you to notice these brackets. These brackets mean particular things. They mean that that A and B are included in a set of elements. And I'll give you a perfect example. If I've got this number line, goes to 0, or starts at 0 there, 1, 2, -1, -2. If I wrote this, that would be a solid dot, 2 solid dot, and all the numbers between -2 and 2 are included in this set, and including -2 and 2 itself. So now this other notation here, see that is a parentheses as opposed to the bracket. that means A is included in the set of elements, but B is not. So what that would look like on the number line would be something like this. There's A included, but B is not. So on the number line, that would look like this. 0, 1, -2. And you'll have to bear with me if you're just adjusting to my poor penmanship. I call it Mintonese. If you had me for Math 1 last year, you probably have gotten used to reading it. For those of you that have not seen this before, I'm sorry, but feel free to clarify or ask questions, and I'll try to set straight what number I was attempting to write with my messy handwriting. Okay, so back to this thing right here. If -2 is included and +2 is excluded, then the dot is not filled in. So that means all the numbers between -2 and 2 except for 2 itself, right? 2 itself has been excluded, right? That's the B in this scenario. And if it has double parentheses, it means A and B are not included. And that would look like this in this same example, and it would be 2 open dots. So I hope that makes sense. I'll give you a moment there, and we're going to move on to the next section of the guided notes. Continuing on, intervals are important because they basically are defining our answer set. And there's several different ways to write them, and we need to be familiar with how to write the intervals in each way. So you can write an interval, or an interval is also a set, right? It's basically a collection of elements, and there's inequality, set notation, and interval notation. And I've kind of shown you a little bit on inequality and interval already in the previous example. So the only thing new here is in set notation, they use this bar. And that vertical bar, it's a shortcut. It means such that. So this bracket X, vertical bar X, greater than symbol 1 is read as the set of real numbers X such that X is greater than 1. So that covers that example and the different ways to write these. And let's take a look at some examples with prepared number lines. So I've drawn 2 different intervals on a number line, and now we're going to write them in the 3 ways that we can. We're going to show it as an inequality, as a set notation, and as an interval notation. So as an inequality, this would look like -3 x is less than or equal to, or -3 is less than or equal to x, which is less than or equal to 2, right? That's basically saying x is between the -3 and the 2. In set notation, I would do these brackets, x, vertical bar, and basically then I list the inequality. See, that's not too hard, it just sounds complicated. And I do the bracket. And then an interval notation, right, that would be this type of bracket, -3, 2. And now when you and I are communicating about an answer set, and we're both mathematicians, you'll know exactly what I'm talking about if I list this right here. I'm simply trying to indicate that the answers exist between -3 and 2, and they include -3 and 2 as well as answers. So let's do the other one here. Because of the open circle, it's not less than or equal to x, it's simply less than. And there's a closed circle over the 2, so that stays the same. The set notation is fairly simple. X, vertical bar, all real numbers x, such that x is between -3 and -2. And then the last one, I'd have to use this type of parentheses because I have to exclude -3 from the answer. 2, and then the, I guess the sideways staple looking bracket. So let's do a few more examples, and that'll conclude your first formal lecture on section 1.1. So here we go. The previous intervals we looked at were finite, and they were bounded on two sides, and that's what it means to be a finite interval. But these other ones are infinite intervals, and they are unbounded in one direction. So as an inequality, this would look like that's supposed to be a 2 right there, and this is also a 2. The circle is filled, so as an inequality, x would be less than 2. And then set notation, I would do the funny looking bracket. X, vertical bar, stands for such that x is less than 2. And then as an interval notation, this is going towards the direction of negative infinity. Over here would be positive infinity. Here's positive infinity, negative infinity for this example. It's supposed to be sideways 8, not an actual 8. So as an interval notation, it would look like this bracket, negative infinity, 2, and I include the 2, and I forgot less than or equal to, right, because the circle is filled in. So that's that example. And for this one, the circle is open, so it's going to be x is greater than 2. Whether the circle is open or closed, that's technically review from Math 1. I may or may not have the poster up for that by the time we do this lesson, but hopefully I've put it up by then, if you've forgotten some of that. But moving on, set notation, x, vertical bar, all real numbers x, such that x is greater than 2, and then finish with the funky bracket. And then this would look like we're excluding 2, right? 2 is not included as part of the answer. Same reason why it's an open circle there. And then it's going to positive infinity. Now, infinity isn't technically a number, so we can't include it. So you'll notice if it's got infinity here, the bracket is also that parentheses. Every time you use infinity in interval notation, positive or negative. So it because you can't include infinity as a number, it's simply an indeterminate number. Okay, so I've included a couple more definitions here just to refresh your memory. The domain of a function f is the set of input values, and you'll see that word set again, of input values x, and the range is the set of output, input and output. It's the way functions work. You put something in, you get something out. The end behavior of a function describes what happens to the f of x values, or in other words, the y values, or you could also say the output values, right? These are all the same thing. As x either increases without bound, meaning approaching positive infinity, or decreases without bound, approaching negative infinity. So give me a moment. I know this a long set of notes, but we're going to take it slow and just keep plugging along. And I promise you don't have to take these notes every single day. So I'll give you a moment to get all this down. You'll notice at the back of your packet, I've included a breakdown of the chapter, and I plan to do this the entire school year, showing you all the various points. Taking these notes is worth points, and you can use them on tests. So it's in your interest to take them. You get graded on them, and they're also a valuable tool for testing. So now that you've had a moment to get caught up, let's do this last section of the guided notes. So right here, these are just examples. If x increases without bound, the f of x values also increase without bound. You would write that like as x. Remember, this arrow here means approaches. And those of you that had me before know I cannot spell very well. I'm much better at math than I am at spelling. So the arrow means approaches. So as x, basically as x approaches positive infinity, the f of x values approach positive infinity. And the converse of that, as x decreases without bound, so basically as x approaches negative infinity, f of x approaches negative infinity. So that's how that's read. And so let's take a look at this example. Right now, the domain. When we're asking ourselves the domain, we have to ask, well, what are all the possible values of x? It looks to me like x could go this way, and x could go that way, without bound in either direction. So that would look like this. That would be all real numbers. As an inequality, that would mean x is between positive infinity and x is between negative infinity. As a set notation, and let's see, let me see if I can zoom in on this some so I can write better. Oh, that didn't work very well. Let's see. As set notation, this is going to be, I have to write kind of small, x such that basically then you type in this inequality you made and then close it with the funky bracket. And there's an interval notation. It would look like this. Between negative infinity and positive infinity. Now the range, right? X is the domain. Range is the y, right? Here is the f of x values, up and down. X is always side to side. F of x is up and down until you get to calculus. Then you have x, y, and z. And then you're in 3 dimensions. But when you get there, you'll see. Okay, range. Doesn't look like y could be any value, does it? Y is definitely greater than or equal to 0. So I would say all positive real numbers. And let me partition this. All positive real numbers. As an inequality, I would say y has to be greater than or equal to 0. And for set notation, I do the funky bracket y such that y is greater than or equal to 0. And the funky bracket. And then as an interval notation, I'm including 0. So I've got the sideways staple, and it goes up to positive infinity. So hopefully that makes sense when you're actually doing this kind of notation on an actual function, and the different ways to write it. And our end behavior, right? We have a right end, and a left end. So as x approaches positive infinity, right, that's this direction, as x gets bigger, what happens to y? Y is getting bigger without bound. Bigger without bound is positive infinity. How about as x goes the other direction? As x decreases without bound, approaches negative infinity, what happens to the values of y? They still increase, right? So there's the end behavior for this particular function. And now we'll get into the MyHRW classwork exercises. And then for homework, you'll also have those worksheets included in your packet. So